Welcome to the video about logical connectors. So this is a continuation of our video about logic. We've already covered what a proposition is, what a negation is. So now we're going to go into combining propositions through the words and or. So an and statement is when you're given two propositions, P and Q, you could form a statement P and Q. And this is called their conjunction. When we're talking about logic, we're really concerning ourselves with whether or not something is true. So we've talked about whether or not a proposition is true, and now we're going to talk about whether a conjunction of two propositions is true. And so here we'll find out that it's only true if P and Q are both true, but let's look at a truth table to kind of see this for ourselves. So we're going to have a column for proposition P, a column for proposition Q, and then we're going to look at P and Q together. And so you might be thinking, well, why are there 4 rows? You need to put all the combinations that are possible for true and false for 2 propositions. So they could both be true, they could both be false, they could be true then false, false then true, and we'll see that set up here. So I like to give a little context. Let's let proposition P be that I am bored, and proposition Q can be that I'm hungry. And I feel pretty confident that with these 2 examples, I'll capture the entire audience here. So P and Q would be the statement, I am bored and hungry. This is a terrible combination. So if proposition is true, if proposition P is true, and if proposition Q is true, then obviously you could say I'm bored and I'm hungry, because think about this. Someone asks you, are you bored? Yes. Are you hungry? Yes. Are you bored and hungry? Yes, it follows. I've already said yes to both of those things. Why are you asking me again? So that one's true. But if proposition P is true, you're bored. But proposition Q, you're hungry, is not true. You couldn't say that you're both bored and hungry. So unless they're both true, you can't say I'm bored and hungry. Conversely, we could look at proposition P being false and proposition Q being true. Again, they're not both true, so you couldn't say that their conjunction is true. And then certainly if you say no to both of them, they're both false, I'm not bored, I'm not hungry, then, well, you definitely couldn't say you're bored and hungry. So again, a conjunction is true only if P and Q are both true at the same time. So notice in the third column, the only time we have a true in the third column is when I have P is true and Q is true. Other than that, it's going to fail and it's going to be false. Let's look at an example. The sky is blue and Elvis Presley is alive. All right, so because Elvis Presley is not alive, this whole statement is false. Remember that they both have to be true. You might be thinking about whether or not this is a conjunction. It is a conjunction. Proposition P, the sky is blue. Proposition Q, Elvis Presley is alive. The word that connects them is and, A-N-D. So this is a conjunction. And we know that for a conjunction to be true, both propositions individually have to be true. And Elvis Presley is not alive, and I don't want to hear another word about that. How about this example? I'm watching a lecture on logic, and today ends in Y. So proposition P would be, I am watching a lecture on logic. Proposition Q would be, today ends in Y. The word connecting the propositions is and, A-N-D. So this is a conjunction still. So I need to make sure that both propositions are true. Is it true that I'm watching a lecture on logic? Yes, if you can hear the sound of my voice saying these words, then you are watching a lecture on logic. Is it true that today ends in Y? Yes, all days end in Y. So whatever day it is right now for you, it's ending in Y. And so both of these propositions are individually true. Therefore, the conjunction is true.